All right. So here's just a little bit of notes talking about the arithmetic sequences we started yesterday, okay? So let's just do an example. Let's say you have 18, 14, 10, ... This is going to be your example. The first thing you should know how to find is what the A1 is and what the D is. Remember? Hopefully, many people are remembering what the A1 is. The A1 is the first term of the sequence. So the A1 is 18. And D is what is happening each time. A lot of people say 4. But if you say 4, that means it's adding 4 each time. So this one technically is a negative 4. Okay? Once you know that, then we were talking about 1, the recursion. I think there's 2 R's. I'm not sure. It's either 2 R's or 2 S's. I'm sorry if I'm spelling it wrong. The recursion formula. It's AN equals A. Notice how I write a little n minus 1 in the corner. And then plus D. Some people are writing it like this. Let me show you how not to write it. They write AN, then AN minus 1. No, it's not a big A. We're not writing a sentence here. This is not English class. It's A with the little n minus 1 plus D. And in the recursion formula, there's really only one important thing you need to look at. You need to look at what is back here, because this tells you what the common difference is. So this is the only thing that you need to plug in for the recursion formula. Everything else stays the same, stays the same. We don't really use the recursion formula that much. The second thing is the function formula. The function formula is the good old y equals mx plus b. And do you remember, we just talked about it, but do you remember what the m is? The m is the same thing as the common difference. So that's negative 4x. And then we have to find the b. The way to find the b is you could use stat edit. Or you can just look at your pattern and tell me which number would have came before 18.
22.
So yes, you have to think backwards. If I'm subtracting 4 going this way, I'm adding 4 going backwards. So the one number that comes before the 18 would be a 22. So that's my function rule, my formula, function formula. If you're running out of space, you could use the back, or try not to write so big. You got the big paper, too.
I know. It's because I was writing down here, and then...
Okay. And then the new one is the explicit formula. And the explicit formula helps because if you have an explicit formula, then you don't have to come up with the function formula. And you can still put the explicit formula in the y equals. All right. So the explicit formula is a sub n equals a1, which we do know what a1 is, plus d parentheses n minus 1. And there's only 2 things that need to get plugged into the explicit formula. A sub n just means that's the term we're going to be looking for. It's any term we're looking for. However, what is a1? A1, look at this, the example.
18.
A1 is 18. And what is D?
Negative 4.
D is the common difference. And then n minus 1 stays the same every time. So only 2 things get plugged in. The A1 gets plugged in, and then D gets plugged in. The only thing is, sometimes on tests, they like to trick you. So they will write it by putting D with the parentheses in front and then the A1 back here. But notice, is your D still a negative 4?
Yeah.
Yes, so sometimes they'll put it up here in the front and then they'll put the positive starting point. Whether it's positive or negative, it will still be your starting, not the starting point, but the first term, I should say. It's definitely not the starting point, it's the first term. And one more thing. This is really good because this, you can put this in the y equals. Put in y equals -4 parentheses x minus 1 plus 18. And then you could find any term they ask for. If they ask for A22, they can ask for A25, they can ask for A92. You just simply look in your table, in your XY table. All right?